All right, so let's do one last example. This time we're going to use the cosine function. Again, we were using our model where we changed both the amplitude and the period. So running straight through it, the first thing we do is we establish our amplitude. In this case, our amplitude is the absolute value of A. So we're going to say our amplitude is 5. Our period is found by taking 2 pi and dividing it by whatever number is multiplied by x. So in this case, it's going to be 2 pi over 3. That's not reducible. So right away, we have our period, 2 pi over 3. But we want to get the location, how far apart the increments, our key points are. So key points are going to be found by taking the period and multiplying it by 1/4. We're going to take 1/4 times the fraction 2 pi over 3. Working that through, multiply numerator to numerator, denominator to denominator, and reduce. We find that this is going to reduce to pi over 6. So each of our key points are pi over 6 apart. So we need to make up our table here of values. Our table of values are going to go as follows. Our x values are going to start at 0, and each of the increments will be pi over 6 apart. So on the left right here, I will show my incremental values in terms of pi over 6. We start at 0, add pi over 6, we get 1 pi over 6. Add pi over 6 again, that'll give us 2 pi over 6. Notice I'm not reducing at the moment. We will in a moment. One more gives us 3 pi over 6. One more increment of pi over 6 gives us 4 pi over 6. But in our table, we're actually going to reduce these values. So 1 pi over 6, well, that's not reducible. Pi divided by 6 is our first key point. 2 pi over 6, 2 and 6 share a common factor of 2, so that's pi over 3 is our next key point within one full period. 3 pi over 6, 3 goes into 6 twice, so we get pi over 2 as our next key point, and then 4 pi over 6 reduces to 2 pi over 3. That is equal to our period, and so we're done, 2 pi over 3. Our domain will be all real numbers, negative infinity to positive infinity. For the y values, we're going to take each of our y values and multiply them by -5 this time. So if you recall our cosine template normally would have gone, let's put this in purple right here, normally would have gone 1, 0, -1, 0, and 1. But we multiply each of these by a. So we multiply times -5 to get our new key point. So what's going to happen right here, our y values will be -5 when x is equal to 0, 0 when x is equal to pi over 6, +5 when x is equal to pi over 3, 0 again when x is pi over 2, and -5 when x is equal to 2 pi over 3. Our graph, well, it will look like every other cosine graph in the world ever. We're just going to be changing the points at which we put our x values. So right here, we start at 0. We have 1/4 of our period at pi over 6. We have 1/2 of our graph completed by pi over 3. We have 3/4 of our graph completed at pi over 2. And we have 1 full period completed at 2 pi over 3. If we were to continue on, by the way, with our gradations right here by adding pi over 6's, we would be at pi at this next unit over here. Now, our y values, we're going from -5 to +5. That's our range. -5 to +5. That's based on our amplitude above and below the x-axis. So we're going to go to 1, 2, 3, 4, 5 along our vertical axis here for our maximum. 1, 2, 3, 4, -5 here below the x-axis for our minimum. Since our cosine function starts At 0, -5, that's where we put our first point. We're going to pass through 0, pi over 6, 0, pardon me, pi over 3, +5, pi over 2, 0, 2 pi over 3, -5 again, and we follow this pattern around for one cycle. We're going to go in this manner. And if we were to continue on with this pattern again, we would start to see the following happen right here in more than one cycle. Suspiciously like a sine graph, but there it is. There's our function. All right, so the assignment will include lots of this graphing, including changes in the period and the range. Good luck.